This here is going to be tougher than what you were doing. It's similar in a lot of ways, but what you were doing before was called simple inequalities, where we only had one like greater than sign or less than sign or greater than or equal to. Now we're going to start dealing with mathematical sentences, so to speak, that have like two or more of these inequalities. So have you guys talked about intersection and union before? Really? Okay. Then Roman numeral 1 is going to be intersection. Intersection. When you think of the word intersection, you probably don't think of math. You think of streets, and where the streets intersect or where they cross is the intersection, right? So if you have two roads, say my green road, and I don't know if I draw this thing out, but I'm just trying to make a point. So if I have my green road, I have my red road. The intersection is going to be that part in the middle. That's part of the green road and part of the red road. Yes? Should have picked yellow, then I could have a yellow brick road. Okay. So intersection is going to be the thing that's on both, right? So intersection uses the word and. I'm going to throw that in my title. So intersection is and. So as you're going through your homework problems in here, if you have things where you see the word and, they're talking intersection, which then would be different than Roman numeral 2, which is going to be the union. And if you had to like define it, I'm going to put a little star for dramatic emphasis and say intersection is going to be only what's in both. So only what's in both. Actually, I don't want that. So only what's in both. So for us now, it's not going to be two roads. It's going to be two different mathematical sentences, two different inequalities, and the intersection is going to be what's in both. So my first example then is I have my x is greater than 2 and x is less than or equal to 4. So x is greater than 2 and x is less than or equal to 4. I'm going to take this one here and change the color. Okay, now if we want to graph these two, we could say, all right, on my first one, x is greater than 2, I'd have a 2, open circle, close circle, open, and we shade to the, yep, that way, towards the parking lot and freedom. So shade to the right. Yeah, risk of sounding like Mel Gibson and Braveheart. All right, the next one. X is less than or equal to 4. Now we have our 4. Open circle, close circle? Close circle, and we shade to the left. So we have our two different solutions. Note my big shaded arrows. Try to get you in that habit. So now, for those, the intersection of those, so the final answer is going to only be what's in both. So if we were to take, and I'm going to try to put those together in one line down here. So if I have my 2 is there, my 4 is there. The part that's shaded twice would be if you could take and kind of put one line right on top of the other. So maybe if I take that 2 and drop it down on this one, I had this here. So that part between my circle on the 2 and the circle on the 4 is going to be what is shaded twice. So I still have to have my open circle on the 2 and my filled in circle on the 4, but my answer is going to be everything in between those two. So something like that. So red then is going to be the final answer. Does that make sense?
Yes.
If it helps to do the, here's the first one, here's the second one, and then here's the third one, you can do that until you get good at it, but eventually, probably soon-ish, you just jump down to the final answer and just write down the stuff that's included in both. Fair enough? What I often did was I just would like make one number line like normal, but then I would real lightly shade the stuff, and then once you see like where it overlaps, then just shade that part darkest. Fair enough? And I'm okay with that on a quiz as well. If you wanted to take and write this, so say we wanted to write, well, how could we say this answer here? How do you say everything between 2 and 4, not including 2, but including 4? Does anyone want to take a stab at that? Maybe let's do it this way. We have here x is greater than 2. If we flipped those around, so instead of x being first, we had 2 on the left and x on the right, what sign would go in between? X is greater than 2 or 2 is less than x. So you agree I could say 2 is less than x like that?
Yes.
And then, actually I'm going to move that over slightly. So I'm going to say 2 is less than x. Ooh. So 2 is less than x. And I'll get rid of that. Now for my blue one, we had that there was x is less than or equal to 4. Still tracking with me?
Yeah.
Well, if we take and just kind of copy these down, we could say 2 is less than x, which is less than or equal to 4.
Yes.
And that there is going to be a compound inequality. It's really 2 different inequalities put together into one.
How can we have this offset 2 and the x?
Good question. Because we're trying to say x is all the numbers between 2 and 4, including the 4. So if you want to write it as one thing, you have to swap the order just to get the 2 on the outside. Yeah, Josiah?
I have a question about this.
If we have these,
What year do you
Start taking
okay, solving these. So you'll see some now. So I'll say solve and graph. So with this, now we'll do something like negative 4 is less than or equal to x plus 5. This you could solve, right?
Yes.
What would you do to both sides?
So,
Minus 5. Now I'm going to add to it, which makes it a little bit tougher, and say that whole thing is less than or equal to 17. So negative 4 is less than or equal to x plus 5, which is less than or equal to 17. So now it's a compound inequality. Do you solve it the same way? Yes, no? Your guess would be yes. That to get x by itself, I'm going to subtract 5, right? That's going to give me an x all by itself in the middle. But if I subtract 5 from that middle chunk, what else do I have to do? Yep, subtract it from both of the others. Subtract it from 17 and subtract it from negative 4. So my final answer then is going to be a negative 9 is less than or equal to x, which is less than or equal to 12. And if one of those maybe was just a less than instead of a less than or equal to, yep, just copy the sign down like we did there. So now final answer for graphing it. What does the left side of my graph look like? Negative 9. And right there I have a closed circle. The right side of my graph is with a closed circle. And in between, shade it. Because x has to be between those two numbers. So for intersection, yeah. Yes. Except for, can I flip pages? Actually, I can do this here. The exception is going to be something like this. And I wouldn't put this in my notes. I don't think it comes up for you guys at all. Say I have a x is greater than 5 and x is greater than or equal to 7 or something like that. This here, well, if I were to do my x is greater than 5, that's going to be this here with an open circle shade right. Agreed? And then if I were to do my x is greater than or equal to 7, filled in circle, shade to the right. So the final answer is just going to be the stuff that's shaded twice. So for this one, my final answer would just be this here in orange, because that's what's also, so that the orange stuff was what shaded in purple and shaded in green. Is that an okay? I don't think that shows up at this level. I don't remember seeing that in the homework, but I looked at this a few days ago. Is that legitimate? Okay. Then, all right. Should I do one more like that last one, or should we call it? The second section is going to be Roman numeral 2, and this is going to be union. So union uses the word or. So I'm going to put that in quotes up there with the title. Now if you think about how unions work, unions want to have all the members. So say you have like the United Auto Workers Union. I don't know where you stand politically. Some people like unions, some people don't like unions. But let's say you have like GM. If they can get where all of their employees are, well, the union wants to have all the employees be in the union. Because if they decide, okay, wages aren't high enough, then what they do is they strike, right? So if you have all the employees in the union and they tell GM, okay, we need better benefits, we want more pay. If GM says no, then all the workers quit and walk off the job. So now General Motors is losing all kinds of money because they're not making any money because they're still paying the employees health insurance, but they're not making any cars to sell. So unions get their power by getting like everybody all involved. Or if instead your union has like 5% of your employees or like 2 out of your 1,000 employees are in the union, if they strike, who cares? It's like you have your other 998 people still making parts. So the point is this: unions try to get like everybody in the union, and in math, a union is going to be like everything that's in one or both. So union, everything in one or both. Where before intersection, the answer was just what's in this inequality and in this inequality. For union, it's going to be whatever's included in one of them has to be in the final answer. So if we were to do an example, so my first example is x is less than 4 or x is greater than or equal to 6. So now as I go through and try to do this, I'm just going to blaze through this because you guys can graph these in your sleep by now. But you agree that's going to be my x is less than 4? Open circle on 4, shade left. So now I have my x is greater than or equal to 6, which gives me then a filled in circle on 6, and I shade to the right with the arrow being shaded. Now if this were intersection, the answer would be nothing, right? Because you agree nothing is shaded twice there?
Yes.
So if we were doing intersection from before, the answer would be the empty set or does not exist or is nothing. Here with union, both of those are going to be the answer because anything that's shaded once is the answer. So the answer is exactly what's written on the screen there. How'd I do?
Do you still want us to
That makes sense.
combine them into
Nope, that's you're good. You're done. Because this here, they don't overlap. So you can't say. But yeah, give it on one number line. Your answer on one number line. If I were to jump to a different problem, I'm going to say for this example, solve and graph. So solve and graph. And now I'm going to have two different things. Negative 5 plus 3x is less than or equal to 7. Or 4x minus 6 is greater than 22. Sometimes you'll find that it's the same, I hate to say the word equation, same expression. It'll be negative 5 plus 3x is less than or equal to this, or negative 5 plus 3x, but it doesn't have to be that same negative 5 plus 3x. For these, we just go through and solve them separately. So my first step here on the left is to do what to both sides? Nice. I was wondering if people say plus 5 or subtract 5. You have this plus here, but it's a negative 5. So to move the negative 5, we have to add 5. And I just do it over there on that inequality. So I have a positive 3x is less than or equal to 12. Divide by 3. So then I get x is less than or equal to 4. I don't switch the sign because I divided by a positive. Now I could go and do the same thing over on this other side. I'm going to start by adding 6 to both sides. And I'll say 4x is greater than 28. And then divide by 4. X is greater than 7. So really for these, doing union, it's really just two separate problems. And now I could go through and I could graph these. So I have on the one side, I have x is less than or equal to 4. So that'd be a filled in circle. Shade to the left, make sure to make my arrow. Then on the right-hand side, I have x is greater than 7. So open circle, shade right. X is greater than 7. Yep. So that number line there, right here, would be the final answer. Because it's whatever's included in one of them or both. So you just include whatever's shaded at least once. If for this one, I'm trying to see if I left it on here. Nope. I lost it. Okay. Maybe I should do this here. For union, let's say you had a problem that looks something like this. With 3, shade this way. And this here is 7, shade this way. If we were talking union, what's the answer going to be for this with union? Everything. So if you had one like this, the green includes everything bigger than 3 to the right. The purple includes 7 and everything to the left. So if you're talking union, it's whatever shaded at least one time. So it's going to be all real numbers for that with union. All right, the very last section in the notes, Roman numeral 3, is going to be the writing inequalities. This is why there's not homework due tomorrow. So writing inequalities. Oh, the writing inequalities part is going to be, here's a graph. So here's a number line with a graph on it. And then you need to figure out, is it union, is it intersection, and how would you write that down? How would you write, can't really say equation, how would you write the inequality for it? So my first example, so example 1, I have a number line with an open circle on 2, and then a filled in circle with 9, and then we shade everything in between. So the first, I'll give you a second to copy it. The first step for that, I think, is to say, well, does it look more like union or does it look more like intersection? Intersection, nice, because it doesn't have like a going for forever. It's not two separate parts. So that's going to be an intersection. Anyone want to take a crack at how they'd write it? You kind of have two options. Zoe, go for it.
2 is less than x, which is less than or equal to 9.
Okay, so if we look at that, the 2 is less than x. Do we like the less than?
No, greater than.
Well, I was more thinking open circle. Do we like that it's an open circle? Open circle means it has to be like a less than or greater than, right? And so I heard a lot of people saying greater than because we're shading to the right of it, but if, I'm going to take and hack her thing apart. If you just look at that end, 2 is less than x. Do you agree that's the same as x is greater than 2? Yep, so we like it. So that left end is good. So left end is good. Let me get rid of the rest of my hacking away at the red. All right, so we like that. The x is less than or equal to 9. Do we like that side too? Yep, so perfect. So very nicely done. That'd be one way to write it. The other way you could do it would be to do something like this instead. And hers is the best answer, but want to throw this other one out there too. We could say x is greater than 2, or you could have done 2 is less than x, but x is greater than 2. And we could have done x is less than or equal to 9. And what word could we throw in between there? And. I like hers the best, but just kind of want to throw that other one out there as an option. You could write it, you could not write it, but technically you could do either. Fair? Then, let me look. I guess one more example, and then we're done for the day. So example 2. So I have this one here. So a number line, open circle on 6, shading to the left, and open circle on the 10, welcome, shade to the right. So now if we have that, union or intersection for that one? Union. So because it's two separate parts, it has to be union. There's nothing in common of those two. So if it's union, then we're going to use the word or. And we have 2 inequalities. Anyone feel like taking one of those two? We could say x is less than 6. Very nice. Dana and some others. Or the one on the right would be perfect. Very nicely done, Josiah. X is greater than 10. And that there would be our final answer. We can't combine, because it's union, we can't combine them into just one compound inequality. So your answer would have to look like that.